now. Okay, so today we're going to be covering Chapter 1, Section 1.6 and 1.7 because we didn't have time last class. Now, there's no agenda for today, so all you're going to do in your notebooks is start from here, Section 1.6. Okay, so if you weren't here last class, we did an activity regarding tables, right? We got into our squads and made ourselves a bar graph according to uh, the data that we collected. And look under the vocabulary of data. Data describes real life situations, okay? So when you guys were collecting each other's data for heights, what age you are, and what grade level you are, that's collecting data, real life situations, okay? Now, we drew bar graphs, and there's other forms that you can interpret information data, which is bar graphs, and you have charts like these. For example, the Guam disasters chart that I just made up. So these information is not true, so it's just made up information for your benefit of the lesson. Okay, so Guam's disasters. Look under year. Okay, it's on the left column with other categories under Guam disasters. There's year, typhoons, and earthquake. So how you would read this, you would correspond the numbers from the right according to its label on the left. Okay, very simple. So you see year on the left, then the corresponding numbers to the right of year is the year 2000, 2005, 2010, 2015. Then, if I ask you guys what was the number of typhoons that happened in the year 2000, and what is your response right now? I'll give you a second. Okay, you should have said 2. How about the number of typhoons that happened in 2010? Okay, it should be 3. Alright, so you guys should know how to read charts like these now. It's pretty simple, okay? You just go according to what's labeled to the left or from the top of it and use them as your reference to guiding you and navigating through the charts. Okay, so all you're doing is just answering questions regarding to the charts, graphs, whatever you see. That's it. You don't have to worry about making these. Okay, so let's look at questions that pertain to the chart that I made. Okay, look at letter A. What year did Guam have the most typhoons? Okay, so what year did Guam have the most typhoons? And if you answered 2015, then you are correct because 2015 had 4 typhoons that occurred. Not saying it's true, okay, it's just something that I made up. Now, let's go to the second question. What were the total number of earthquakes from 2000 to 2010? Okay, so you're gonna look at the years from 2000 to 2010, in between those years. Now you see the numbers of 5, 8, and 2. So what the question is asking you is to add up the numbers between those years. So we have 5 plus 8 plus 2. And what does that give you? It should give you a total of 15 earthquakes that happen in between those years. Okay? So that wasn't too hard. And that's all you're basically doing for this section. So don't be worried about making graphs or anything. Just have common sense and just read the charts and the graphs and just relate it to the questions. That's why we did that activity, to warm you guys up and to just critically think and think for yourselves that these questions should relate to the graph, and if not, then answer it to the best of your ability. Okay? Alright, so let's move on to the next page. Okay, Miss S&D, if you can please pause this video so that the students can get about 5 minutes to copy this down. Okay, so you should have finished copying this down. Now, line graphs. Line graphs is what you're going to see in this section as well. Like I said, you're not going to draw them, you're actually just going to interpret them. And the example that I provided is very close to the book, but I made it up so that you guys can answer it on your own when I give you the assignment. Okay, so right now the line graph that you see is an example of the amount of rainfall that happened each month. And the rainfall is measured in inches. Okay, and you can see that right there. And it is like related to the book, like I said, so you can reference it when you do your work. And when you do your work, I'm probably going to be with you, so you don't have to worry about that right now. Now, let's read the instructions. Based on the graph, decide whether each statement is true or false. So all you're saying is true or false. You don't have to give an explanation if it's false or if it's true. So don't take it don't think about it too hard. Okay, so letter A. Rainfall increased each month. Is this statement true? Yes or no? So all you're going to look at is the graph. So you can see from January to February, it's increasing. But from February to March, it's decreasing. March to April, it's increasing. April to May, it's stabilizing. Then from May to June, it's decreasing. So when the statement says rainfall increased each month, is that true? And your obvious answer should be false. If it was true, then you would see the line graph increasing constantly like this. Okay, or at some other type of behavior, but it's always increasing, not like my black line where it increases, decreases, stabilizes, decreases. Okay, so that should make sense. Alright, let's go to letter B. The rainfall was about the same in the months of April and May. Is that true or false? So look at the months April and May. So were the amount of rainfall about the same? And if you can see the line, it should be straight enough to tell that they are the same. So the statement is true. Okay? If there are any questions, then I'll be glad to answer them when I come back. Or if I am back, then I would be answering your questions already. So this is actually the end of 1.6. I made it super simple for you guys. All you're doing is interpreting graphs, line graphs, bar graphs, charts. That is it. Just information given, then answering questions. Okay? Questions like true and false, which should give you either 50-50 chance of getting the correct answer, but you should get 100% correct because it's easy questions to answer. And questions like these where you actually have to look at the graph and get information and actually, answer the questions as it wants you to answer it. Okay? Alright. Now if there are no questions, then we'll move on to section 1.7. Now Mrs. S&D, can you please pause the video and give these guys time to copy these down? Alright, so going on to an introduction to functions. This encompasses a lot of Algebra 1, so it is very crucial that you guys really pay attention to this section specifically, okay? Because you will see this a lot in the upcoming chapters and sections, and without you guys knowing this, you guys will get lost, okay? But this is very easy. Always tell yourself it's easy, and it will be easy. Okay, going to vocabulary. Function. Function is a relationship between two quantities called input and output. So if that definition bores you, look at the stars that I made, or the definition that's given in between the stars, okay? So remember this. For each input, there is exactly one output, okay? Repeat that to yourself again. For each input, there is exactly one output. Alright? So that is very important to know. Now look at the definition of domain. Domain is a collection of all input values. And input values are represented as the letter X. Okay? And I'll put that to the left of domain. Okay? they're represented as X, or I should use blue. Okay, they should be represented as X, and you'll see why later on. Okay, so domain can be read as input and is read as the letter X in your variables. Alright, then look at range. Range is a collection of all output values. Okay, so for output values, the letter representing outputs or range is Y. Okay, and like I said, range can be also called outputs. And there's a reason why I'm color coding this, so you would see it in the examples. Okay, and you'll get to know and understand these terms better when we go through the examples and do it yourself. Okay, so input and output table examples. Okay, so as you see, we have this little chart over here, and you should have copied it down, and you just follow along. Now, in the input value, we have the numbers 0, 1, 3, 4. And how many numbers are there in the input value? Yes, there's 4. Now, in the output value, we have the numbers 3, 1, and 2. And the amount of numbers that are in the output value is 3. Okay, so just follow along with what I'm about to do. So 0 goes to 3. Okay, 1 goes to 1. 3 goes to 1. And 4 goes to 2. Okay, you might not understand what I'm doing now, but just understand the concept of this definition right here, what I said with function. For each input, right, the input values is 0, 1, 3, 4. There is exactly one output, which is to 3, 1 is to 1, 3 is to 1 again, 4 is to 2. Okay, and this right here is called a function because it follows that definition. Okay, it is a function. Now, let's look at the other examples and determine if these are a function or not. Okay, these two right here. Now, 1 goes to 3, 2 goes to 4, 3 goes to 5, and 4 goes to 6. Now, if somebody can answer, is this a function? Yes or no? Judging by the definition given of a function, yes or no? Okay, whoever answered yes, it is a function, then you are correct. Okay, because for each input, there is one output. Okay, 1 to 3, 2 to 4, 3 to 5, 4 to 6. Okay, so it is a function because for each input there is exactly one output. Now, let us go to the second or the last example. Okay, so 1 goes to 3, 1 goes to 4, 2 goes to 5, 3 goes to 6. Now, is this a function? If you answered yes, you're wrong. Okay, you are wrong. It is not yes, it's actually no. It is not a function. And why is that? Can somebody answer that for me right now, even if I'm not there? I'll give you 5 seconds. Okay, that should have been 5 seconds. Now, if you said no because we have 2 of the same input values, which is 1 and 1, then it violates the definition of a function, which is for each input there is exactly one output. But now look at this. 1 goes to 3, right? That is one input to one output, but 1 also goes to 4. So it violates saying that for these same inputs, you're getting 2 different outputs, which is wrong because 1 should only have one output. Does that make sense? Okay. Now let me throw you a little bone to give you a more clear idea. Now, what if I had this? Let me draw another chart for you. Okay. So you guys already know that the left side is the input and the right side is the output. So what if I had these numbers written down? If I had 1, 2, 3, 4, and if I had on the right side, on the outputs, 3, 3, 4, 5. Okay, so, and like I said, the left side is your input, which is your x, right? And the right side is your y. Now, if we go 1 is to 3, 2 is to 3, 3 is to 4, 4 is to 5, is this a function? If you answered yes, you are correct. It is a function. Okay, because notice on the right side, we have two of the same outputs when you have 1 to 3 and 2 to 3, but it does not violate the definition of for each input there is exactly one output, because 1 is different from 2, not like this example right here where we have two of the same inputs, but there's different outcomes, different outputs. Does that make sense? Okay, so I'll give you a minute to collect that in, and so should copy this down if you haven't done so. Give yourselves 30 seconds. Now, let us do this page. So Miss S&D, please pause the video so that you can give them time to copy this. Now, you should have copied this down. Now, this is a problem found in your seat work. Okay, so let's go read through the instructions. Make an input output table for the function. Use 0, 1, 2, and 3 as a domain. Now, you're given this problem, y equals x minus 1. Now, the input output table is what you just saw, what we previously did. So, you're going to make that table. That same table I made. Okay, and like I said, it's divided to the left side and right side. The left side being the input, then the right side being the output. Okay, x and y. Oops, that's not supposed to be a circle. Okay, now, like the instruction said, you're going to use 0, 1, 2, and 3 as the domain, and we said the domain was the letter what? It should be the letter x, okay, which is right here. So you're going to put the numbers 0, 1, 2, and 3. Now listen very, very carefully, because this is the bread and butter to the sandwich that you want to make, or that didn't make sense, but the breakfast you want to make. You have to plug in these x values, the 0, 1, 2, 3, into this function, this type of equation. So what I mean by that is, so first you're going to replace x with 0, and like I said, make that habit of putting parentheses, right? Now, 0 minus 1 is what? Negative 1, right? And negative 1 is in the place of y. So you're placing y in the box with negative 1 next to 0, because you replaced x with 0 and you got the answer with negative 1. Does that make sense? Okay, let's go to the next one. Okay, so we have, when we replace the next x with 1, right, because that's next in the box, 1 minus 1 gives you what? Gives you 0. So when you get that answer 0, you're writing that answer next to the 1, because you replace x with 1. Okay, and you got the answer 0. Okay, let's go to the next one, and I'm for sure you guys are getting it now. So you're replacing x with 2 this time, minus 1 gives you 1. Okay, so in the y, you're putting next to 2, 1. Alright, next one. You're replacing the last x with 3, and 3 minus 1 gives you 2. And you're putting next to 3 in the table 2. Okay, Oh, and probably I mistaken charts for tables, so my bad. Now I am realizing that what I mean by charts is tables, okay? So that is on me. So that I was referring to tables when I was talking about charts in 1.6. Okay, do you guys know how to solve functions now? Okay, it's very, very easy. All you're doing is plugging in the numbers of x and just getting the results of y, and x is already given to you in the instructions above, okay? So you have to really read the instructions carefully. This is very, very easy. Just follow the steps correctly, okay? So I want you guys to do the second one. Alright, so let's do it together. Okay? This should be very, very easy. And if you're already ahead, that's perfectly fine because that's what I want you guys to get to. Okay, so we make that chart again. And we said the left side was our x, right? Our input values. And our y is the right side. Okay, so what are we putting under the x? What was given? 0, 1, 2, 3. Okay, it's in the instructions above, right over here. Okay, then we're trying to find our y's, so we're just plugging in our x. Okay, so when we replace x with 0, so what is 5 times 0? It should give you 0. Anything times 0 should be 0. Okay, now what if we replace x with 1? What is 5 times 1? It is 5. Okay, and you're putting 5 next to 1 because you replace x with 1. Now next, we replace x with 2. What is 5 times 2? It's 10. Okay, then we put 10 next to 2 because that's what we replace x with to get 10. Now, lastly, we replace x with 3. 5 times 3 gives you 15, and you place 15 next to 3 because that's what you replaced x with to get 15. Okay, easy so far. Now, you're going to encounter these problems in your textbook and the assigned seat work that I give you, but you will do that seat work when you guys see me next class, okay? Now, if you guys have that PDF that you found online, alright, so you can use that to do your work now if you don't, because I didn't have time to print worksheets, and I don't want to waste paper. So if you have those PDFs that you found online, you can do the work that I'm about to go to. So with this work given, just do it on your own, and if you can share that PDF like with your neighbor, like just show them what's on your phone, you can do this work together, okay? It'll be due next class, or if you weren't able to do it, then I'll give ample time to finish it next class, okay, when I see you. Now, Miss S&D, thank you so much for covering my class, and you can pause this video for them to copy these problems down, and I will see you guys next class. Okay, have a great day.